It's my pleasure to be moderator for this fourth in the series of MIPI Debug webinar series for 2024. Today's session will be a preview of MIPI Debug over UCIe. As you can see, it's a joint session between MIPI Alliance and UCIe Interconnect Express organization. I have two expert speakers lined up. I have Aruni Nelson, who is technical lead for MIPI Debug over UCIe specification and also principal engineer at Intel Corporation. And we have a guest speaker, Peter Onneferk, chair of the UCIe Manageability and Security Working Group and fellow at Intel Corporation. So let me just give a little bit of housekeeping before I hand over to my expert speakers for today. Okay, without further ado, I shall hand over to Aruni just to start today's session.
All right, so thank you all for joining. And as part of this session, we will go over some of the terminologies which we will be using throughout the session. Peter will then cover what is UCIe technology, what is UCIe manageability and debug, and then we'll introduce what is MIPI's new Debug over UCIe specification. We will go over the goals and requirements we had in mind when we started the development of the specification. We'll then talk about why the specification is being developed in MIPI, in case you're wondering about that. And we'll look at a couple of system architecture examples where Debug over UCIe can be used. And we will also look at how UCIe defined constructs, specifically the management transport packet, is planned to be used for sending debug requests and receiving debug responses. We'll briefly look at some of the debug requests that the specification will support, and then we will close with Q&A this session. So before we dive into the presentation, here are some of the terminologies. DTS, or Debug and Test System. It's a system which could be a combination of hardware and software, which provides a system developer debug visibility and control when it is connected to a target system under debug. And this is where your debug application and software runs. And target system, or TS, is the system under debug. Management bridge is a device that may be needed to bridge the connection between the DTS or debug host and the target system, that is SIP with, or system in package with multiple chiplets in this case. SPP, or the SneakPeek Protocol, is MIPI defined debug protocol, which kind of abstracts the system designer from dedicated debug communication interfaces such as JTAG and replaces them with familiar mechanisms of address, map, read, and write transactions. Then we have STP and TWP, System Trace Protocol, Trace Wrapper Protocol. They are also MIPI defined protocols for formatting, timestamping, and extracting traces from target systems. Debug entity is a component within the UCIe chiplet that is an independent compute element, such as microcontrollers or microprocessors, which can be debugged. And you all have heard network adapter a lot in the last few sessions. It's the entity that provides translation between MIPI-defined debug protocols and the transport underneath it, in this case, UCIe management transport. UCIe, or Universal Chiplet Interconnect Express, is an open industry standard for a common interface for connecting chiplets within a package. And chiplet is a modular integrated circuit die, which is designed to perform, say, a specific function as part of a larger system. And UCIe manageability is UCIe specification defined framework and capabilities to manage a UCIe-based system. And system in package is nothing but a collection of chiplets into a single package to create a complete system or subsystem. So with that, I will hand over to Peter, who will cover UCIe technology.
Thanks, Aruni. So before we dig into UCIe and MIPI Debug over UCIe, let's take a step back and talk about what is UCIe. UCIe stands for Universal Chiplet Interconnect Express, which is the name of a consortium that's developing technologies to enable an open chiplet ecosystem. The vision is that future system and package designs, also called SIPs, will be developed by integrating chiplets designed and manufactured by different companies. This slide summarizes die-to-die technologies that have been standardized by UCIe. Unlike other die-to-die technologies that have only focused on the physical layer, UCIe has standardized the entire protocol stack. The protocol stack is made up of a physical layer which specifies the mechanical and electrical properties of the die-to-die connection, the die-to-die adapter layer which standardizes the link layer and provides reliable transmission of flits between chiplets, and two protocols, PCIe and CXL. We chose PCIe and CXL as the initial die-to-die protocols since they're useful for many die-to-die applications. Also, since they were developed as board-to-board protocols, they already contain all the necessary manageability functions such as discovery, configuration, and error handling. There are three versions of UCIe. A 2D or standard package version called UCIe-S, which supports bump pitches of around 100 microns and a 25mm channel length between chiplets. A 2.5D version called UCIe-A that's intended for use with a silicon bridge that supports a bump pitch of around 50 microns and a 2mm channel length between chiplets. And a 3D version that was standardized in UCIe 2.0 released last August. UCIe 2D and 2.5D supports speeds from 4 gigatransfers per second to 32 gigatransfers per second. And we're working on extending those speeds to 64 gigatransfers per second. So in addition to die-to-die communications, UCIe has also standardized manageability, which defines how you manage a system and package made up of multiple chiplets. In the picture on the right of this slide shows an example of a SIP made up of 4 chiplets. UCIe manageability runs on a management network that operates either over UCIe sideband or UCIe mainband and is separate and completely independent of any mainband protocols. This allows a SIP to be managed independent of the mainband protocols. So your SIP could have chiplets that interconnect by PCIe, CXL, CHI, or something else, and all of it can still be managed in a consistent way using UCIe manageability. The management network is made up of a management fabric within each chiplet, management ports that use UCIe mainband or sideband to interconnect chiplets, management bridges to the outside world, and management elements which provide management functions. Examples of UCIe manageability applications include things such as discovery and initialization of chiplets, setting configuration parameters and firmware download, power management of chiplets, various aspects of security, and finally, test and debug. MIPI emerged as Moore's law enabled chips on a board to be consolidated into a monolithic SoC. This required development of debug standards since it was no longer possible to debug a system simply by probing signals on a board. A similar transformation is occurring again. As we transition from a world of monolithic system on chips to one where system in packages or SIPs are constructed from chiplets assembled from an open chiplet ecosystem, we need a way to holistically debug these SIPs. This is where UCIe Debug and MIPI fit in. UCIe Debug is an application of the UCIe manageability infrastructure where the management infrastructure is used for test and debug. The benefit of this is that it allows the entire SIP to be debugged as a unit instead of each chiplet having its own ad hoc debug architecture and interfaces. DFX management spokes are where debug functionalities such as core debug, SoC debug, UCIe link debug, and other forms of debug are implemented. DFX management spokes connect to a DFX management hub, which is a UCIe management element that interfaces DFX management spokes to the management fabric within a chiplet. The figure on the bottom right of this slide shows the UCIe management protocol hierarchy. The important thing here is that UCIe test and debug is just another protocol that rides on the management infrastructure. UCIe test and debug itself doesn't provide any debug capabilities. It's simply used to carry other test and debug protocols. And this is where all the debug work that's been done in MIPI fits in. So with this brief introduction to UCIe, let me turn it over to Aruni, who will cover MIPI Debug over UCIe in detail.
Thank you, Peter. Okay, so based on what Peter mentioned about UCIe, UCIe-based systems will increasingly become an important part of computing, especially because of the flexibility it offers in terms of plug-and-play approach of integrating chiplets from different vendors and packaging them together to form a system. And as these systems get deployed, it will become inevitable to support at-scale debug of chiplets within a package, and hence the need for a standard debug over UCIe specification. If you've attended previous sessions in this webinar, there was a session on Debug Over family of specification, and Debug Over UCIe specification is part of that family of specifications. So this specification will provide mechanisms to perform closed chassis in-band debug of one or more UCIe chiplets at any depth in the UCIe topology using the UCIe-defined manageability infrastructure. So on the left here, you can see that Debug Over UCIe sits on top of the UCIe manageability infrastructure that you saw in previous slide from Peter. It utilizes UCIe-defined memory access and test and debug protocols to control and configure the debug capabilities in the target system, in this case, one or more chiplets, and it uses test and debug protocol type for sending debug requests and receiving debug responses. And one thing to note is that this specification will support SneakPeek, System Trace Protocol, Trace Wrapper Protocol, defined by MIPI to achieve run control and tracing. And MIPI openly publishes these specifications, which anyone can access, and I encourage you to go through these specifications. And we do see a lot of benefit for the ecosystem in having a standardized method for debug over UCIe. This standard mechanism will allow debug during development phase of the chiplet and when these chiplets get integrated into the system and package. And since the specification uses UCIe constructs for debug requests and responses, it is in-band over the UCIe link, so it doesn't require external debuggers and custom debug pinouts. So as part of developing this specification, our goal was to, as mentioned earlier, define a standard mechanism to debug any UCIe chiplet that supported UCIe manageability as long as it was addressable. So UCIe chiplet at any depth in the topology in a SIP should be debuggable. And in the MIPI Debug work group, we looked at different combinations of how a DTS could be connected to a target system. We also wanted to have our debug traffic coexist with the functional traffic on the UCIe link. And last but not the least, we wanted to utilize UCIe-defined constructs, capabilities, and feature set to the fullest to achieve this. And in terms of requirements, we will leverage UCIe-defined management transport infrastructure. We will define means to control and configure the target system for debug. We will provide means to send debug requests and receive debug responses. We will support both the capability to perform run control as well as extract traces from the UCIe chiplet, which is under debug, and as part of which we'll use SneakPeek, Trace Wrapper, System Trace Protocol, etc. We will support debug of multiple UCIe chiplets simultaneously, including the debug of any debuggable entities within the UCIe chiplet, which the UCIe chiplet vendor wants to expose. And we will provide hooks to support secure debug sessions as defined in MIPI's security for debug specification. And we will also define debug-related events and interrupts which may require debug host's attention. One of the obvious questions many may have is why is MIPI defining debug over UCIe specification? And you've seen this butterfly diagram many times during this webinar. And the reason is MIPI's debug group has defined several specifications around debug. And MIPI has the knowledge base and the ecosystem through the various debug protocols, the debug software infrastructure, and debug over different interfaces, which can be leveraged for debug over UCIe. And both UCIe Consortium and MIPI Alliance wanted to leverage this. So now let's look at a couple of system architectures where debug over UCIe can be used. And this slide here shows an example of a self-hosted DTS and one or more chiplets that are under debug. And the UCIe bus in the system may be used for both debug and non-debug usages. And in this example, all the green chiplets in the system and package are shown as under debug. And our DTS, or the debug host, is running on one of our chiplets within the SIP. And on the right, we have an example of what the stack would look like for debug over UCIe. And again, you've seen this diagram many times. This just shows the logical entities in the DTS and the TS. And on the DTS side, you can see at the bottom, we have the UCIe stack with the link and the file layer, the UCIe management transport layer, and above that, implementers may optionally implement secure messaging layer based on their security objectives, which could again be implemented based on MIPI-defined security for debug specification. And on top of that, we have what the specification defines for network adapters, which will facilitate the debug protocol specific communication between the debug software and the UCIe management transport layer. And then on top of that, of course, we are showing all the specific debug drivers and the applications. And similarly, on the target system side, at the bottom, we have the UCIe stack. And then again, based on the implementation requirement, there could be secure messaging layer and the implementation of network adapters for specific debug protocols. And then on top of that, we may have infrastructure associated with respective network adapters. And then you have the debug entity or the debug source, which is the entity within the chiplet that can be debugged. And that's the one that provides you the requested debug data. This slide here is an example of an externally hosted DTS. And again, one or more chiplets in a system and package or SIP that are under debug. And again, the UCIe bus in the system can be used for debug and non-debug usages. And in this case, our DTS is running externally outside of the SIP, and it is connected to the SIP over some I/O connection. And this could be USB, I3C, or PCIe, for example. And DTS's interface to the SIP is through the management bridge, which could reside in one of the chiplets in the SIP. And on the right, we have the stack diagram, again, showing all the logical entities involved. And it is slightly different from the self-hosted DTS stack because it involves the management bridge. So in between the DTS and the TS stack, we have shown the management bridge, which other than providing the gateway to the SIP, also supports the translation between the IO-specific packets and the UCIe management transport packets, which carry the debug requests and responses. This slide here is a one-click deeper view of what is in a UCIe chiplet that supports debug over UCIe. So this chiplet should, of course, support UCIe manageability. And you can see it has the same management entities that Peter showed in his slides. And in this UCIe chiplet, you have DFX Management Hub, DFX Management Spoke, which are the key UCIe manageability components, which facilitate the test and debug of UCIe chiplets. And this chiplet that supports UCIe manageability could include one or more DFX management spokes attached to Management Hub. And a DFX management spoke is the one that provides you the interface to the network adapters, which may be mapped or associated to the debug entities within the chiplet. So you can see in this example, a debug over UCIe DMS could be mapped to one or more network adapters, and each network adapter is uniquely mapped to a debug entity. In this slide, we wanted to show the format of UCIe management transport packet, which we will be using for transmitting debug over UCIe requests and responses. And for the details of the management transport packet structure and the fields within, you can refer to the UCIe specification. On a high level, we have listed those fields here. We'll not go over all of them, but just some specific ones. So we have the destination ID here. As you can see, this is basically the management network ID, and the format of it is shown below. It consists of chiplet ID and the entity ID. So with this field, you can reach up to the DFX management hub within the chiplet. Then we have the management protocol ID, and this in our case could be set to either memory access protocol or test and debug protocol, depending on what we want to achieve. And then you have the RESP or the RESP bit to indicate whether this packet is carrying request or response data. And then we have the source ID, which is the ID of the sender of the management transport packet. And it also follows the same format as the management network ID, as shown below, consisting of chiplet ID and the entity ID. We have destination DMS and source DMS, which indicates the IDs of the destination and source DFX management spokes. And then we have the sub-protocol, which would be, in this case, set to vendor defined, because from UCIe perspective, this is defined by MIPI. And we have UCIe allotted MIPI ID to indicate which vendor-defined protocol is supported or carried in this packet. And the gray field here is what carries the MIPI Debug Over UCIe request or response. And this is where we have the network ID and the debug entity IDs. And we have circled some of the fields here to show which fields are actually relevant to reach a specific debug entity within the chiplet. This slide here provides just a sneak peek into the kind of requests we plan on supporting in this specification, which will allow getting details of what is available in the SIP in terms of debug over UCIe, how to configure debug over UCIe, and then start debugging one or more chiplets in the SIP. So as the name suggests, you can get the capability, you can get the list of debug over UCIe capable devices. You can get capabilities of debug over UCIe feature per chiplet. You can configure them. You can start a debug session, stop a debug session, start a specific adapter, reset it or stop it. You can get the state of the adapter. You can execute specific commands. You can read and write to addresses. And those are the ones that will use the UCIe memory access protocol. And then we also have provision for implementation defined request. So in a typical flow, the debug application will basically request for the debug capabilities after it has, so let me back up a little bit. So if a DTS is connected to a target system with one or more chiplets, it can either have the static knowledge of all the UCIe chiplets which support debug over UCIe, or it can request the system to provide the list of UCIe chiplets which support debug over UCIe using the get UCIe capable device list. And once that is done, then debug application can request for debug capabilities of chiplets using the get debug capabilities request to determine the debug entities and the network adapters that are supported by each debug entity, among other attributes. And based on the debug capabilities of each chiplet that support debug over UCIe, the debug application can proceed with the configuration of a debug session using configure debug request, which could also include establishing a secure session as per the security for debug specification. And then the debug application could start a debug session using start debug session, and it could start an available network adapter and then send specific commands to the network adapter using execute debug command. So in conclusion, we anticipate a rise in UCIe SIP-based computing systems, especially with the AI boom and all, and hence the requirement for debugging one or more chiplets in a SIP. And both UCIe Consortium and MIPI Alliance are working towards providing a unified framework for accessing, monitoring, and debugging chiplets, enabling the developers to diagnose specific issues effectively in these highly integrated systems. And development of debug over UCIe specification is one such effort. And on this slide, we've highlighted some of the resources that folks can access and get details on the content and specifications that are published by both MIPI and UCIe consortium. So with that, Ian, I think we can take Q&A.
Yep, thank you, Aruni. Thank you, Peter, for your presentation. Indeed, we can take some Q&As. Can you have a JTAG connected to one of the chiplets and then inside use UCIe or USB/ISP accesses instead of JTAG?
Yes, so you can, of course, have a JTAG connection to a chiplet. And in some cases, you may actually need a JTAG connection. Say if you're debugging, and I'll just give an example, but there may be other examples. So internally, your network is UCIe. There's nothing different, right? Once you have all the chiplets connected, the SIP is supporting UCIe. How you get into the SIP is maybe you have a JTAG connection, but the use of JTAG could be for bare metal debug, or maybe you actually want to, you cannot really send anything on UCIe if UCIe link itself is not working. So that connection could be set up to debug the UCIe link itself. So of course you can connect JTAG to chiplets, and I think one of Peter's diagrams showed that. But when you want to debug, or when you want to send the actual debug requests and responses on the UCIe link itself, that means UCIe link is up, functional, running, chiplets are addressable, they are accessible. And that is when you're debugging the system, where all these chiplets are interfacing, interacting in a functional manner. And in that case, you could have a management bridge, which allows external connection. So those, I believe that should answer the question. If not, please type in the chat and we'll try and address it.
Just add to what Aruni said, the whole point of UCIe manageability is exactly this: one connection and you can debug the entire system. The management infrastructure is outside of the main band protocols, so it's an out-of-band management, and it runs either on sideband, which is kind of what's required, or it can also run on main band for high performance paths. On sideband, the view is the sideband interface is reliable, it's super slow. You should always have it up and running and be able to debug the rest of your system.
Okay, thank you both. Okay, so there's a follow-on question from Robert. What will be the protocol on the external connection?
So the external connection could be anything based on implementer's choice. It could be a USB connection. It could be a PCIe connection. If you have a PCIe connector, it could be an I3C connection. In some cases, you have these USB I3C converters that could be connected. So that I/O connection could be anything. It could be an Ethernet connection. We don't really impose what kind of connection the SIP should offer. What we will try and do is we will have specifications defined around different connections, such as, say, if the management bridge supports USB, then how does that translation work from USB internally to management transport protocol?
Okay, thank you. So thumbs up from Robert. That's obviously answered his question. Okay, if there are other questions, then please fire them into the chat window. One question of my own. Obviously, there's a new liaison between MIPI and UCIe. Any particular technical challenges that are foreseen as part of this deliverable? I'm guessing we have a fairly aggressive timeline to deliver, so I guess we don't foresee anything. But maybe you could add some comments in terms of what the group is going to have to judge.
Yeah, I mean, there are some interesting problems that we should address instead of calling them challenges, or some interesting aspects that we have to take into account as we are developing this Debug Over UCIe specification, because there is a lot more complexity involved here when you're debugging a system in package. It is fundamentally more complex than debugging your traditional systems, because it has multiple chiplets and potentially coming from different vendors. So we do have to take into account that. We have to also keep in mind that we are accommodating for interactions between the chiplets and debugging the system holistically. And one challenge that or problem that we want to solve is managing the bandwidth difference between the I/O connection between the external DTS and the management bridge, which may not be as super high bandwidth as what UCIe supports. And to offset that a bit, we do plan on recommending the implementation of, say, end-to-end flow control, which could be anchored at the management bridge. And other thing is more of alignment between MIPI Alliance and UCIe. This is not really technical, but it kind of gets into that space, is that we are constantly working together to make sure that the manageability infrastructure defined in UCIe has the hooks. We need to advertise and configure the MIPI Debug Over UCIe feature and the relevant hooks to transport the debug requests and responses and events. So, but that is just part of life in this case, that we have to work together and make sure that we simplify these problems and challenges and provide a unified framework for debugging the SIP.
Okay, so it's not just a one-way sort of flow of information. I mean, Peter, do you want to add anything?
No,
Yeah, it is not a one-way flow. In fact, when one of our colleagues was working on this definition of management transport protocol, him and I had several one-on-one conversations to make sure that what he puts in the test and debug chapter of UCIe specification, it gives us those hooks. It gives us that flexibility to for us to send these different debug protocols over the management transport for debug.
Yeah, the partnership between the organizations has been great so far, and I expect a very successful standard and adoption.
Great. Okay. Okay. So one other question for myself. Obviously, you've mentioned already, and perhaps you can expand on this. But obviously, you know, this is a different type of debug environment. How will this kind of influence the test systems that are used? Will they differ greatly from the systems that perhaps people are familiar with today?
Yes. So today, the traditional systems, you have, say, one SoC, and you may have IPs within that SoC, but they're all connected over some internal fabric. In case, and unlike these traditional computing systems, which are monolithic die architecture with system and package, which has this multiple heterogeneous chiplets, debug must address not just individual chiplets, but their interaction across this high-speed UCIe fabric with other chiplets. So in traditional systems, maybe the spoke is more focused on debugging a single chip or isolated subsystems or components. And again, they could be on some internal fabric, whereas this UCIe-based SIP requires, again, the system-wide visibility, covering multiple chiplets. And because these come from different vendors, it is essential that we have this unified solution of debugging, a standard mechanism of solution. And then in traditional systems, mostly the debug tools expect like a moderate latency and moderate bandwidth, whereas while debugging UCIe-based SIP, UCIe is low latency and it has high throughput. So that can overwhelm tools. So we have to take into account those, and that's how it's going to be different to debug the SIP based on UCIe.
Yeah. Okay. So obviously we have this liaison happening between MIPI and UCIe to create this debug solution. Will this be the only game in town when it comes to kind of debugging through these interfaces, or will it be kind of competing with other solutions out there in the industry?
I don't. Go ahead, Peter.
From a UCIe perspective, MIPI Alliance is our debug partner. We're working with MIPI. There may be others that map proprietary debug on top of the infrastructure, but we're not pursuing any other standards activities.
Okay. Nice, clean answer. Thank you. So I don't have any other questions. Hey, if we have anyone for the audience asking or holding on to a question, I'm sure they're probably not by now, but please get that into the chat window ASAP. I guess one last question from me is kind of the obvious one. When do we expect this this activity to kind of complete? When can we expect the specification to be ready?
So our plan currently is that by Q1 of 2026, we would have version 1.0 of the specification published through MIPI.
Okay, so we're looking at sort of just over a year duration, hopefully, to get to V1. Okay, and if anyone listening wanted to get involved, Aruni, what would be your advice?
Yes, I think join the MIPI Debug Over debug work group where we are developing this Debug Over UCIe specification. Participate in that. Give us your feedback there. There is also manageability work group that Peter runs. Join that. Provide your feedback there and see what's happening there. And that'll help you understand how both the different specifications are working together. Peter, do you want to add anything from
No, I think you've covered it. We welcome folks, MIPI folks, please come to manageability if you're interested.
Yep. So if you're one side of the fence or the other, then and you're a member of one or other organization, then there's definitely a way in, and more the merrier to get involved. Okay, great. No more questions from me. Peter, would you like to add anything before we wrap up today?
I'm looking forward to a great partnership between UCIe and MIPI. I think this is, kind of a perfect mix of technologies between the two organizations. And I, want to thank you for inviting me to this webinar.
Oh, well, thank you for supporting us today. Really appreciate it. Aruni, any last words from yourself?
No, I think, as Peter mentioned, I second that sentiment. It has been a great partnership, and the working relationship has been wonderful. Our focus is, again, on how to unify a solution and give the ecosystem a standard that, chiplets coming from different vendors, when packaged, it can be used. So we're trying to ease that a little bit for the ecosystem. And of course, want folks to join in. And if you have any ideas or if you see any gaps in the items that we're trying to address, please bring those forward through these work groups. And we would definitely appreciate that.
Great, thank you, Aruni. I guess one thing to mention, we do have a kind of, although the works can obviously take some time to deliver, we do have a homepage for Debug Over UCIe on the MIPI website already as a kind of placeholder. Obviously, we'll post updates to that page. So if you are interested to kind of track this work, that's one way to do it. Obviously, join the MIPI or UCIe mailing lists. I'm sure you'll see updates in the organizational newsletters that are sent out. Okay, so well, thank you, Aruni. Thank you, Peter. Really appreciate you presenting today and putting together your presentations. And we'd also like to very much thank our audience for tuning in today and listening to what we have to say. So I really appreciate that. I think just one wrap-up slide to go. That's again to mention that we've had 4 sessions this week covering different topics. We had how to get started with MIPI debug solutions first thing yesterday, followed by a preview of the upcoming MIPI security specification for debug. And today we've had an introduction to the new MIPI Debug Over initiative, and this session covering a preview of the MIPI Debug Over UCIe specification. So those 4 webinars will all be available on demand through the link shown on the screen here today. Okay, I think that's done for today. So thank you once again, everybody, and we'll see you soon.